Math 1343, hypothesis test, population proportions. The first few videos in this series are actually going to focus on the general concept of a hypothesis test, at which point we'll transition into conducting hypothesis tests specifically for population proportions. So when I say hypothesis test, what do I mean? Well, let's get the general idea out of the way before we define the stuff behind me. A hypothesis test is essentially a battle between what somebody claims to be true about a population and a sample that suggests your claim about the population might not be true. For example, let's say that I claim at least 75% of students at a university are vegetarians, just making something up. I claim at least 75% of the students at this university are vegetarians. Well, if somebody doubts that claim, they might go find a sample of students and figure out what percent of them are vegetarians. Let's say that these students survey a sample and 76% of them are vegetarians. Would that support the claim? Well, yes, the claim was at least 75% are. But what if the students got a sample, or what if they got a sample of students and only 70% of them were vegetarians? Would that necessarily disprove the claim that at least 75%? At first instinct, you might go, yeah, because it's less than 75. But remember that inferential statistics is based on samples representing populations. If you pick a sample whose 70% of which are vegetarians, does that necessarily mean that less than 75% of the population are vegetarians? Not necessarily. It might be the particular sample that was picked, and not necessarily the fact that the claim was wrong in the first place. But let's say that to challenge the claim that at least 75% of students at a university are vegetarians, somebody takes a sample, and in that sample, only 20% of them are vegetarians. Do you think that would be sufficient evidence to say, wait a minute, I'm not sure if your claim is right, because if your claim was right when I took a sample, I'm not sure if the percent was supposed to be that low. And that's the idea behind hypothesis testing. When you have a claim about a population and you have a sample that probably doesn't support that claim, is the sample strong enough evidence to reject your claim about the population? Or do we just blame the difference between the particular sample that was selected and say, I'm sorry, you disagree with my claim about the population, but you don't disagree by that much? And that's really what hypothesis testing is all about. All right, let's get some vocabulary out of the way. Types of hypotheses. Well, first, we should probably define what I mean by hypothesis. In statistics, a hypothesis is simply a claim about a population parameter. Emphasis on the word population, and the word parameter is just the correct vocabulary word, meaning a variable that measures something about a population. For example, somebody might claim that the average GPA of all students is at least 3.25. You can tell this is a claim about a population by the use of the word all. And what population parameter are we making a claim about? Well, average of all is kind of the same as population mean, which is the variable mu. So we could also write this claim by saying that mu is greater than or equal to 3.25. Because if you're at least 3.25, you are 3.25 or more. It's like saying you're at least 21 years old. Well, then your age is greater than or equal to 21. Or we could say something like this. We'll say 30% of all, I don't know, trucks have, I don't know, kind of painted myself into a corner here. We'll just say have remote start. I'm just making something up. Remote starters. You know, where you can start your truck from outside by pressing the button on your little key thing. Well, this is a percent of a population, the percent of all trucks, so that's population proportion, whose variable is P. And so the claim here is that P is equal to 30% or P is equal to 0.30. All right, so that's all a hypothesis is, a claim about a population. Now, within the realm of hypotheses, there are two types of hypotheses. And by the way, when you spell hypotheses with an E at the end, that's plural. When you spell it with an I at the end, that's singular. Let's partition this. Two types of hypotheses. And for each one, I'm going to give you two definitions, and I'll explain why. The first hypothesis is called the null hypothesis. And there are varying definitions of it, some of which are stronger definitions than others. For example, this definition, a claim about a population assumed to be true unless sufficient evidence to the contrary exists. I get the idea behind this. It's kind of a fluffy definition, but in my opinion, and this is it's precisely that, it's my opinion, this definition is weak. Because in the mechanics behind hypothesis testing, in other words, when we get to step 1, step 2, step 3, this won't be a solid enough definition to go, that's a null hypothesis. There is a more objective way to define a null hypothesis. A null hypothesis is a claim about a population, that permits equality. Now, what do I mean by that permits equality? Well, remember, these claims are about numerical measures of a population. A population's mean, that's numerical. Population's proportion, that's also numerical. When I say a claim about a population that permits equality, that means does this claim allow this variable to equal this number? Or this parameter equal this number? Well, this one demands it. P is equal to 0.30, and this one allows it, or it permits it. Mu is greater than or equal to 3.25. So really, the best way to look at a hypothesis written symbolically in terms of a variable and a number and some relation between them is to ask yourself, does it allow the variable to equal that number? That means that symbolically, you can spot a null hypothesis from a mile away, because a null hypothesis will always include one of three relations. Equal, which not only permits equality, but it flat out demands it. Greater than or equal to, which does permit equality, but it doesn't require it. And then its counterpart, less than or equal to. So if you see any claim about a population parameter, and that claim includes equal, greater than or equal to, or less than or equal to, then you have a null hypothesis. Now, there is a symbol for the phrase null hypothesis. The symbol for the phrase null hypothesis is a capital H subscripted with a 0. It looks like a letter O. It's really a 0. So I'll get into the reason why, because right now it's escaping me. But when you see a null hypothesis, such as one of these two, and you want to explicitly state, you're the null hypothesis, here's how you do it. You start by writing the symbol for a null hypothesis, followed by a colon. It's important to point out that this symbol is not a variable, it does not equal a number. You never put it equal to something. It is simply an abbreviation for the phrase null hypothesis, followed by a colon, and then you write your claim. So we could say that the null hypothesis is mu is greater than or equal to 3.25 if we wanted to state it for that first one. Or we could say the null hypothesis is P is equal, excuse me, that was a colon, but it looked like an equal sign. P is equal to 0.30, or 0.30 if you don't want the leading 0. So those are examples of null hypotheses and how to correctly write them. H subscripted with a 0, colon, and then your claim about the population parameter. Now, by contrast, there's a type of hypothesis called an alternative hypothesis. and loosely speaking, it's a claim contradicting a null hypothesis in light of sufficient evidence. Now, whether or not this is a strong or weak definition depends upon which of these two definitions you latch onto. If you latch onto this one, I consider this a weak definition because this one doesn't explicitly say that the null has to permit equality, which is actually required from a technical standpoint, as we'll see later. But if you want a definition of the null hypothesis along the lines of this stronger definition of the if you want a definition of the alternative hypothesis along the same lines as this stronger definition for the null hypothesis, it's actually pretty easy. A null hypothesis is a claim that permits equality, so it has to be one of these three relations. By contrast, an alternative hypothesis is a claim about a population that does not permit equality. A claim about a population that does not permit equality. And so by contrast, instead of having an equal sign, a greater than or equal to, or less than or equal to, it has to have one of the three following relations: is not equal to, is greater than, or is less than. None of those three relations allow things to be equal. This one explicitly says you're not equal. This one says you're greater than as opposed to greater than or equal to. And similarly, this one says less than as opposed to less than or equal to. The symbol for an alternative hypothesis is actually inconsistent. I've seen two different symbols from the two different books that I've taught this course from. The symbol that we're going to use is an H subscripted with an A for alternative. So for example, let's say that somebody claims the average GPA is at least 3.25. What would contradict that? Well, could I put this? I would argue no, even though it has a valid relation. This alternative hypothesis that the mean is not equal to 3.25 doesn't necessarily contradict this null hypothesis. Think of it this way. Is there an average value that would make both of these true simultaneously? Sure. What if the average GPA was 3.5? It would make this true, and it would make this true. So the truth of this alternative hypothesis does not necessarily guarantee that the null hypothesis is incorrect. In fact, there's only one symbol I could put here. I couldn't put greater than because then these two agree pretty much all the time. The only difference is when mu is actually 3.25. The only symbol I could put, the only relation I could put for an alternative hypothesis corresponding with this null hypothesis is mu is less than 3.25. Think of it this way. When you have a pair of hypotheses, and they always occur in pairs, they're a valid pair if the truth of one of them guarantees the other one must be false. In other words, if mu is at least 3.25, then it can't be less than 3.25, and vice versa. If mu is less than 3.25, then it can't be at least 3.25. Now, this other null hypothesis, where we said the population proportion is equal to 30%, what would contradict that? Well, the obvious choice is, well, it's not equal to. And that would be a valid alternative hypothesis for this null hypothesis, because if one is true, the other must be false. That's the truth-value relationship between a null and an alternative hypothesis. When one is true, the other one has to be false. If the proportion is 30%, then it can't simultaneously be not 30%. But what about this one? That would actually be a valid alternative hypothesis to this null hypothesis, because if P is 30%, then this has to be false. And if P is greater than 30%, then this has to be false. And similarly, less than would also be a valid alternative hypothesis for this null hypothesis. Again, because if one is true, it forces the other one to be false. So how do you know which one to use? Well, it will almost always be contextual. I will say this, though. In a lot of the problems we're going to be doing, in some of the problems that we're going to be doing, you'll be given an alternative hypothesis but you won't be given a null hypothesis. I'm just going to put this as not equal because I wanted to. Doesn't really matter. Without context, I have no reason to put anything there, anything particular. But as I was saying, sometimes in the statement of a problem, you're given a proposed alternative hypothesis, which you can identify because the relationship does not permit equality, and you're not given a null hypothesis to contradict it. In the absence of a clearly stated null hypothesis, assume it says equals. In other words, if you're not given a null hypothesis in the context of a hypothesis test, you assume it says equals. There are some teachers in some books that say, yeah, it's always equals. That's not true. It's convenient, but I've seen null hypotheses that can't be equal because they say things like at least or at most, which would be greater than or equal to or less than or equal to. So here's what you need to take away from this video. This is the symbol for null hypothesis. This is the symbol for alternative hypothesis. And by the way, in some textbooks, they use an H1 instead of an HA to contrast the H0. So number one, you need to know these are the symbols for null and alternative. Number two, you need to know that a hypothesis is a claim about a population parameter, meaning that when you write a hypothesis, you never write a sample statistic. You never test if X bar is equal to something or P hat is equal to something. You measure samples. You don't have to speculate what their values are. But we can't measure populations often, and so we have to speculate, hence these claims. And number three, null always permits equality, alternative never permits equality. And number four, for a pair of hypotheses, and my apologies, they're not really paired up very well. Here's one pair. Here's the other. For a pair of hypotheses concerning their truth values, if one of them is true, it has to force the other one to be false. Otherwise, it's not a valid pair. So notation, always about a population and the relationship within a pair of hypotheses.